Let's talk about the BGP Flowspec configuration. As you can see, we have a service provider, and inside of this service provider, like the RTBH, we have a controller. We call it Flowspec controller, and also we have two clients, Flowspec clients, router 2 and also router 4. And also we have three customers: good, suspicious, and attacker. What is the goal of this scenario? The goal of this scenario is that the good customer, means router 6, can reach to the web server without more check or security check. But suspicious traffic from the router 8 first should go to the security device like a firewall, any other type of device. For example, IDS, IPS, other types of security devices. And after checking, after ensuring that the traffic doesn't have any malicious part, the traffic can go to the web server. But the attacker traffic should drop at the edge of the network. Actually, here we have three types of action. First, we want to specify the flows in the Flowspec controller, and after that we need to define which action should be done on each type of the traffic. This is the BGP Flowspec capability, and as you can see, it's more than RTBH. In Flowspec, you can define different match condition like source IP, destination IP, layer 4 parameters, or maybe features related to the packet, like the length of the packet or fragment or some other things. Also, we have different actions. You can say please accept the traffic, you can say please drop the traffic, or you can say please redirect, or some other actions. Because of that, let's configure this scenario. But before configuration, let me inform you that about the Flowspec controller. As I know, you can implement it on iOS XR device. Actually, iOS XR device is capable of running the Flowspec controller, and iOS XE and maybe iOS, cannot do this job. Flowspec controller, and after that, about the Flowspec client, you can't use XRV if you use the XRV, because XRV doesn't have the hardware forwarding capability. Because of that, in this scenario, I use the XRV for Flowspec controller, but for Flowspec client, as you can see here, I'm using the iOS XE. Let's configure this scenario. We can better understand the BGP Flowspec. First, in step 0, we have initial configuration. We have iBGP full mesh between the router 1, router 2, router 3, and router 4 for address family IPv4. And we have iBGP neighborship, again for address family IPv4 between the router 2 and router 5. And also router 4 and router 5. Why? Because I will enable the Flowspec address family, the new address family between them. And after that, we have also eBGP neighborship between the router 2 and router 6 and router 2 and router 8. And also between the router 4 and router 8 and router 4 and router 7. Here you can see the initial configuration. I configured these commands previously, and you can use these commands to configure your scenario. And we start from the step 1. In step 1, before configuring the BGP Flowspec, we need to ensure that we have connectivity between the router 6, router 7, and router 8, and also the web server. Here you can use these commands. Actually, this is before the implementation of BGP Flowspec. Let me check. From the router 6, this is the router 6, we can use ping command easily. You need to use ping, the IP address of the web server, 100.0.0.10, and then source loopback 0. The loopback 0's IP address is quad 6 in the router 6. Show IP interface brief. As you can see, we have this IP address. Also, in router 7, again, I'm going to use the ping command, ping 100.0.0.10 with the source of loopback 0. We have connectivity. And also in router 8, again, the same command, ping 100.0.0.10 with the source of loopback 0. We have connectivity. This is the step 1. And now we can start configuration of the BGP Flowspec. First, you know that in BGP Flowspec, we need to send the flow specification and also the action from the Flowspec controller to Flowspec client. It's okay. Because of that, for the first time, we need to enable this new address family. Actually, in BGP, we have a new address family in BGP. We call it address family IPv4 Flowspec. Because we have iBGP neighborship between the router 5 and router 2, and also router 5 and router 4 for the IPv4, you need to enable only address family IPv4 Flowspec in between the router 2 and router 5, and also router 4 and router 5. We have iBGP neighborship between the router 2 and router 5 only for IPv4 address family, not IPv4 Flowspec. Let me show you here. In the router 2, we can check show BGP IPv4 unicast summary. Okay, show BGP IPv4 unicast summary. As you can see, we have iBGP neighborship between the router 2 and router 5, but this is for IPv4 address family. Okay, if you check show BGP IPv4 and then for example Flowspec summary, okay, you can see that we don't have any neighborship between the router 2 and router 5 for advertising Flowspec information. Because of that, first we need to enable this address family between the router 2 and router 5, and also router 4 and router 5. This is like the other address family configuration. Only you need to go to the router BGP mode, address family IPv4 Flowspec, and then activate your neighbor. This is the command that we need in iOS means or iOS XE in router 2 and also router 4. Let me show you here. I'm going to use router BGP 65000 address family IPv4 Flowspec. Okay, and then enable neighbor or activate neighbor 5555. That's it. This is the command we need in router 2. But now also we need to configure the router 5 also. First, router 4. In router 4 also we have similar condition like the router 2. Again, router BGP 65000 for address family IPv4 Flowspec. Please activate our neighbor quad 5 actually activate. And in actually, you know that in XRV in the Flowspec controller we use iOS XR. In iOS XR, first, we should enable this address family under the router BGP, and after that we need to activate it for each neighbor. Because of that, address family IPv4 Flowspec is the first command that you need, and then you need to exit this mode, and after that neighbor quad 2 enable this address family. Here we don't use activate actually. Address family IPv4 Flowspec, that's it. And then again neighbor quad 4 address family IPv4 Flowspec. Let me to show you. Here in the router 5, we go to the router BGP mode, router BGP 65000, and then first address family IPv4 Flowspec. Now we enable this address family, and then for neighbor quad 2, okay, when we need to use the address family IPv4 Flowspec. That's it. And again, neighbor quad 4. Okay, or maybe you want to use exit and then neighbor quad 4 address family IPv4 Flowspec. And you know that finally we need to commit this configuration. All right, now we have IPv4 Flowspec activation or neighborship, BGP neighborship between the router 2 and router 5, and also router 4 and router 5. We can check in the router 2. we can use show BGP IPv4 Flowspec summary. As you can see, we have neighborship with router 5, but we didn't receive any information. For example, in show BGP IPv4 Flowspec, we don't have any information. In router 4 also, you can check it, show BGP IPv4 Flowspec summary. We have neighborship with router 5 for this address family, and until now we didn't receive any information. Actually, we will receive flow information and also action from the router 5. This is the next step in configuration. Step 2, BGP Flowspec peering configuration between the router 2 and router 5 and router 4 and router 5. Let's go to the step 3. In step 3, we need to configure class map. Actually, we want to say which traffic or how the edge routers can match the traffic. Here, this is like the MQC or modular QoS CLI that I expect that you know about it from previous courses. Here we need configure class map to configure class map in the router 5, and then after the class map configuration we will configure policy map, and then we apply the policy map or we service the policy map. Don't forget, here we use class map type traffic, not the actually quality of service class map. This is the class map work on the traffic. Because of that, we say class map type traffic. Okay, here you know that we have 3 types of traffic. The first type of traffic is receiving from the good customer, and we don't want to check it or redirect it or drop it. We want to pass it. Because of that, I'm not going to configure a policy for the good customer, but I want to configure 2 types of class maps. First, for the suspicious customer, and for the second, for the attacker customer. For the suspicious, okay, I'm going to use this command, class map type traffic, match all, and then the name of the class map. The name of the class map is, this is for attacker, the red, and the type of this class map is traffic class map. And you know that we can configure 2 logic, match all, match any, and you learned about them in the previous courses. In match all, you say all of conditions should match, and then the class map will match the traffic. Okay, because of that, for example, in the red traffic class map that we define for attacker, we say match destination address is the IPv4 100.0.0.10 quad 255. This is the web server IP address, and also match source address IPv4 quad 7. This is the loopback 0 IP address of router 7. Actually, we say if you receive, we want to inform to the edge routers, router 2 and router 4, if you receive a traffic with the source of quad 7, with source IP of quad 7 and destination IP of 100.0.0.10, this is the traffic of class map red, and then finally we will apply it a policy, an action actually. And for orange class map, we say match destination address IPv4 100.0.0.10 quad 255 means the traffic with destination of the web server, and source address, for example, is quad 8, means the loopback 0 of the router 8. This is the traffic from in the class map orange. Don't forget, here you can use different match conditions. I will show you. Okay, but for now, in the router 5, in the controller, let's start configuration of the class maps. Look at here. First, you need to say class map type traffic. It's very important. And after that, the logic is match all in our scenario. Okay, and then the name of your class map, for example, red. Okay, and here, like the MQC or quality of service class maps, you have different match conditions. Look at here. You can use each one that is suitable for your scenario. Match a destination port, destination address, or source port, source address, protocol, precedence, packet lengths, and some other things. As you can see, we have many options. Okay, for our scenario, I'm going to use match destination address. Okay, and after that, which address family, IPv4, IPv6, or MAC, IPv4 is good for us. And which IPv4 address? The IPv4 is 100.0.0.10 and quad 255. We have many options. You can check them. This is the first match condition, and second match condition is match source address, and then IPv4. This is for red, for attacker, and in attacker the loopback 0 of router 7 has quad 7 as the IP address, quad 7 quad 255. That's it. Okay, this is the first class map type traffic. The second class map type traffic, class map type traffic, and then match all is logic, and after that the name can be orange or any other name that you want. Okay, and after that match again destination address. Okay, and IPv4 the same destination address 100.0.0.10 quad 255. As you can see, we configure these commands on the controller, not on the edge routers or client routers. Okay, and also match source address is IPv4, and after that the loopback 0 of router 8 means quad 8. Okay, quad 255. Now we have these two class maps, but we didn't apply any policy to them. Let me to commit them first. Okay, let me to cancel it and then commit. And now you can use show class map, then type traffic to monitor your class maps. Class map type traffic match all red, and this is the first class map and this is the second class map. But in router 2, as you can see, until now we didn't receive any information from the router 5 because we didn't configure policy map and also the Flowspec. I will show you also in the router 4. Okay, this is the next step. Now we know which actually traffic is desired for us. The next step is configure policy map type traffic for red and orange. For red class, we want to drop the traffic in both router 2 and router 4. For the orange class, okay, we want to redirect the traffic to the firewall or to any security device. Okay, the IP address of the firewall is quad 10. Okay, because of that, we define this policy map. Policy map type, the policy map type is PBR, that because we want to drop some traffic and also redirect some traffic. Policy map type PBR, the name of the policy map is the FS or Flowspec, any other name. Here, for the class type traffic red that we defined before, action is drop. Okay, for class type traffic orange, action is redirect to IPv4 next hop. Here again we have many options that you can use them. For other traffic, please actually only because the default action is accept, only accept traffic and don't do anything on them. That's it. This is the policy map, but you know that we need to apply it. Only here we define this policy map. This is like the policy map in the actually quality of service, but don't forget here we use policy map type PBR, and also we need policy this is the difference that we have. And also in classes we say class type traffic red, not class red. Okay, because it's possible that you have class red for quality of service, normal class, and also you have class type traffic. You need to identify which class is the class that you want to match. Okay, and after that, here in the router 5 again, I'm going to configure policy map, and then this is the policy map type PBR, any name, FS. For class type traffic that we defined with the name of red, here we have many actions. Look at here. Our action for this class is drop, but we have other actions that you can use them. Let me to use drop. And after that, for class again type traffic, and after that orange, okay, we want to redirect. The action that we want to use is redirect. Redirect, configure the redirect feature. This is the redirect to IPv4. This is the IPv4, and then next hop. Which next hop? Quad 10. This is the loopback of I configured on the firewall. Okay, that's it. And for other traffic, you know that we use class default. Again, I'm going to use class default, type class first, type traffic, and then class default. Okay, class default, you need to type it. That's it. Now we have our policy map. Let's commit it. And after commit, you can check show policy map. Okay, and then type PBR. You can see your policy map. Policy map type PBR, class type traffic red, and action is drop, class type traffic orange, redirect to this next hop, and class type traffic class default. Also in router 4, if you check, again we don't have any information received from the router 5, and also in router 4. Why? Because we didn't say to BGP, please send this Flowspec information. All right. And the next step is applying this policy to the Flowspec. You need to configure to go to the Flowspec mode, and for address family IPv4, apply this policy map with the same command that we use in quality of service policy, type PBR, and then the name of your policy. Okay. In the router 5, I'm going to configure this first, Flowspec. Now we are in the Flowspec mode. Okay, Flowspec. This is a Flowspec. Look at here, Flowspec. That's it. And after that, here you know that we need to use service policy command. Okay, for address family IPv4, service policy type PBR. Don't forget, you need to use type PBR, not only service policy like the quality of service. Because of that, here I'm going to use address family IPv4, and it is important to say address family IPv4. Okay, because this is for IPv4, or maybe you have a service policy for IPv6. Okay, and here address family IPv4, we have these address families, IPv4 and IPv6, and after that, now you can use service policy. The type is PBR. Okay, and after that, the name of your policy is FS. And after commit, now we have this information in Flowspec. Because of that, BGP will send the Flowspec information from router 5 to router 2 and also router 4. Now you expect to see this information, means include the actually BGP match condition and also action in router 2 and router 4. In router 2, first show BGP IPv4 Flowspec summary. Now we receive two actually NLRI to BGP update, one for the red class, one for the orange class. And also in the router 4, we have similar condition. And then in router 2, you can check show BGP IPv4 Flowspec. This is the flow information. If destination is 100.0.0.10/32, and if the source is quad 7/32. Okay. And also, the next stop is quad 0, because it means that you need to drop it. And actually, for the destination 100.0.0.10/32 source is quad 8/32, you need to send it to the quad 10. In router 4 also, we have a similar condition. Let's check it. Show BGP Flowspec or show BGP IPv4 Flowspec. We receive similar information. Also, we have some show commands that you can use them. For example, we can use show Flowspec IPv4 NLRI detail, okay, on the controller on the router 5. This is the information that we have. Show BGP or show Flowspec, and then IPv4, and then NLRI and detail. Okay. You can see that we have this information. This is the hex of our NLRI, and after that the action. And until now we don't have any traffic. This is the traffic rate. And after that, here we can see the next NLRI information, and then this is the next hop that we define. Also, the next command is show Flowspec NLRI again. And after that, the IPv4 first, and then NLRI, And after that, we can use, for example, internal. Here we have more information, more detailed information. For example, again, NLRI action and also other information related to the match condition, or actually to the class, and also to the action. About in the clients like R2, we can use show Flowspec. Again, actually here we can use show Flowspec, and after that IPv4 NLRI and then internal. Okay, we have similar information. Traffic rate is 0, and also about the next NLRI we have this information. And also we can also use the show Flowspec client, because this is client. Show Flowspec client. As you can see, this is the client state is connected to the controller, and we have 2 flow until now. Actually, it means that we received 2 flow from this neighbor, from this controller, router 5. Also in router 4, we have similar command, show Flowspec client. But let's check the functionality of it. First, in the text file, you can see we can trace between the router 6, router 7, and router 8 with 100.0.0.10. Okay, I want to show you, if you send traffic from router 6 to the web server, it will be okay. From router 7 means attacker, it will be not okay. And from router 8, it will actually pass the firewall or the actually security device, and finally can reach to the server. Okay, let's first send a ping command, ping ICMP echo, and then use the trace route. In router 6, we use this command, ping 100.0.0.10 with the source of loopback 0. Okay, yes, it's okay. Also, we can use trace route 100.0.0.10 with the source of loopback 0. Look at here, router 2, router 1, router 3, router 10 means 2, 1, 3, 10. It's okay. And also from the router 7 means attacker. First, I'm going to use this command, ping, then 100.0.0.10 with the source of loopback 0. As you can see, traffic will not reach to the server. Actually here, the R4 will drop the traffic, but I can check it with traceroute command, traceroute 100.0.0.10 with the source of loopback 0. Okay. As you can see, traffic in router 4 will be dropped. And then in router 8. In router 8 also, we can use ping command, ping, and then 100.0.0.10 with the source of loopback 0. Okay. We have connectivity, and then traceroute 100.0.0.10 with the source of loopback 0. Okay. Traffic went to the router 4. Also here, don't forget, because we want to receive the answer of traceroute, the devices inside of the service provider does not have or do not have the actually IP address connectivity to the quad 8. Because of that, maybe you see some asterisks, but it's okay. As you can see, router 4, and after that, the first router is the router 4, and the second router is 10.4.10.4. 10.4.10.4 is the IP address of the gigabit 5 of the router 4. And after that, router 3, it means that it send it here. Look at here. First, traffic went to the router 4, 10.4.8.4. And after that, reached to the firewall, but firewall cannot send an actually answer to the router 8. Because of that, here you see asterisks, and then router 4 again come back to the router 4, and then to the router 3, and then to the firewall. But let me check again. Yes, we have similar conditions. Maybe it's possible traffic went to the router 2 from router 8, and then firewall, and then router 4, because here we have load balancing. If you see asterisks, it's okay. Finally, it reached to the router or actually to the web server. As you can see, it's working, and it means that with BGP Flowspec, we have more functionality and more granularity in compare with the BGP RTBH. Why? Because we can define more match condition, more conditions to match the traffic or flow, and also we can define more actions. Okay, because of that, Flowspec is the advanced feature in compare with the RTBH. Also, now we can understand that BGP Flowspec supports client-server architecture, and the router acting as a server, or means the controller actually, inject the Flowspec NLRI entries, and the router acting as client, here Flowspec client, receive the NLRI from the controller and programs the hardware according to the instructions defined in the Flowspec NLRI entry. Okay, and don't forget, because the controller, means router 5, is responsible for injecting Flowspec entries, the controller should be configured with the policy map and should be associated to enhance policy-based routing, or EPBR. Okay, enhanced policy-based routing, EPBR. The controller configuration is done in the Flowspec configuration, as we did here. Okay, after the Flowspec configuration is done, a new address family is enabled on BGP for advertisement and connection establishment purposes between the server and the client, and this configuration is similar on both the controller and also the client. On the client side, the only thing to ensure is that the Flowspec peering is functional between the controller and also the client. Okay, and also notice that we can use show commands to verify the functionality of Flowspec. For example, we can use show Flowspec IPv4 NLRI detail in router 4, show Flowspec IPv4, okay, NLRI then detail or internal, to see that we have some traffic, okay, as you can see, matched with the actually first class map, okay, or first flow, and also second flow. Here you can see them. In the first class map red, as you can see, all traffic received or matched are dropped. But in the next flow, in the next class map, we can see all traffic matched, and also none of them are dropped, all of them are redirected. Alright, BGP Flowspec defines a new NLRI with an AFI value of 1 and a SAFI value of 133 for unicast traffic filtering, and also a SAFI value of 134 for VPN traffic filtering. Okay, every Flowspec route can be understood as a rule consisting of two parts: match and action. Okay, the matching part is encoded in the NLRI field, and the action part, okay, is encoded as a BGP extended community. In this table, in the green table, you can see Flowspec NLRI type for match criteria. Type 1, destination IP or IPv6. Type 2, source IP or IPv6 address. This is type 3, not type 4. Type 3, IP or IPv6 protocol. Type 4, source or destination port. Okay. Type 5, destination port. And after that, here we can see type 6, source port. Type 7, ICMP type. Type 8, ICMP code. Type 9, TCP flags. Type 10, packet lengths. Type 11, DSCP, and type 12, fragmentation bits. Actually, it means that you can use this match criteria for matching the traffic in the Flowspec. And also in blue table, we have extended community value based actions. For example, here you can see the community values and also the PBR action, drop or police, then terminal action, sampling, redirect, set DSCP, redirect IPv4 or IPv6 next hop, and also this is the description. Actually, it means that we can use the Flowspec for defining different and various match criteria and also actions. Don't forget, the default action for a traffic filtering flow specification is to accept the traffic that matches a particular rule that, as you remember, we experienced it in the class default in our scenario. Alright, in our scenario, I captured the gigabit 0 of the actually router 5, and this is the BGP update, as you can see. And here I'm going to find the information related to the Flowspec pass attribute. And here we have pass attribute MP reach NLRI. And inside of it, you can see that we have NLRI, network layer reachability information, for the Flowspec NLRI. If destination is 100.0010/32 and source, this is the source prefix filter, and here we can see the extended communities. This is the extended community, and you know that we use different extended community. For example, this is the extended community type 08. And also you can see it means that 0800, 08 is first byte and 00 is the second actually byte. Here we have transitive Flowspec redirector to IP next hop. This is for the actually quad 7. Look at here. Here we have MP, this is the next hop. The next hop is 10.10.10.10, means 0A, 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 0A. And here also we have the Flowspec NLRI. We have here we can see quad 8. You know that quad 8 is the for orange, okay? And if as you remember, we should forward it to the firewall or redirect it. Because of that, in the NLRI, okay, we have this information, the flow information, and also in the extended communities we have the rule. And if you capture again, you will see that we have other information received, other BGP update for Flowspec for the quad 8, and the action will be dropped. And here you can see now we have 0800. As you can see in the action table, the 0x, okay, 0800 means redirect to IP next hop, or redirect IPv4 or IPv6 next hop. As a result, we can say BGP Flowspec or flow specification is a feature that provides a way to perform traffic filtering and rate limiting based on specific flow characteristics, such as source and destination IPv4 and IPv6 address, IP protocol, source and destination ports, and more. Okay, Flowspec allows network operators to distribute traffic filtering and rate limiting rules across their network using BGP, which can help mitigate the impact of DDoS attacks and other unwanted traffic patterns. When Flowspec is enabled, the router receives a specially formatted BGP NLRI message containing the flow characteristics and the desired action to apply to the matching traffic. The router then uses this information to dynamically create and apply traffic filtering and rate limiting policies. And finally, to configure Flowspec on a Cisco IOS router, you need to enable BGP, configure a BGP session with enabler, and configuring BGP policy templates with the desired traffic filtering and rate limiting actions. Additionally, you may need to enable Flowspec client functionality and configure the router to accept and install Flowspec routes.